Yes, today's class we go for another example comes under the greedy method, that is minimum cost spanning tree. So we will learn how to find the minimum cost spanning tree using Kruskal method. This is the graph capital G, which is represented by capital V comma E, where V represent set of vertices and capital E represent set of edges. So this is the graph is available. So let us know how to compute this minimum cost spanning tree from this graph. First one. So we need to find or we need to collect the edges from graph capital G. So this is the graph, and from this graph we need to find what are the edges are there. Second one. So while finding the edges, you need to collect weights also. Next, we need to arrange these all edges in ascending order. Ascending order, which ascending order based on the weights. This is the second step. Next, third step. So we need to pick the one edge from the sorted weights. Pick edge, and we need to include this one. We need to include into minimum cost spanning tree. When do you include this edge? If that edge doesn't create a cycle. If the edge doesn't create a cycle or doesn't form a cycle. So like that, we need to continue this one until all the edges are completed. So here, after completion of this, we need to test whether generated graph is a minimum cost spanning tree or not. For that, we need to test how many vertices are there in the generated tree and how many edges are there in the generated tree. So if these values are like this, number of vertices in the generated graph, if it is equals to number of edges plus 1, then we say that generated tree or graph is said to be the minimum cost spanning tree. Otherwise, which is not a spanning tree. So let us know how to do this one step by step. The first one. What is the first step I did? I said find or collect the edges and weights from the given graph. So here, this is the given graph, and here I am writing the edge, and here I am writing the weight. So what is the first edge we have? I need to start from 1. Is there any direct edge from 1 to 1? There is no direct edge. Is there any direct edge from 1 to 2? Yes. We have edge between 1 to 2 and whose weight is 55. Next, we have edge between 1 comma 3. Yes. 1 comma 3 is another edge whose weight is 25. Next, what is the another edge? 1 to 4, we have direct edge and whose weight is 45. Next, another edge, 1 to 5 is direct edge does not exist in the given graph. 1 to 6 no edge, 1 to 7, 1 to 8. We do not have. Next, we will go for second edge. So what are the adjacent edges or what are the edge assigned with the let us count. So 2 comma 1, we have edge. Already I have written that one using 1 comma 2. This is not directed graph. So when you write 1 comma 2, so you need not to write 2 comma 1 because that both represent the same. So 2 to 1, no need to include. 2 to 2, there is no direct edge. 2 to 3, we do not have edge. 2 to 4, no edge. We have edge from 2 to 5. So what is the weight of this one? 5. Next, 2 to 6, no. 2 to 7, no. 2 to 8, no. So we have only one edge from 2, that is 2 to 5. Next, I will go for 3. So 3 to 1 is there, but I won't include this one. 3 to 2, no edge. 3 to 3, no edge. 3 to 4, no edge. 3 to 5, we have edge, and whose weight is 40. Next, 3 to 6, we do not have edge. 3 to 7, 3 to 8, 3 to 9, we do not have. Next, we will go for fourth one. So from fourth vertex, 4 to 1, 2, 3, no need to check. 4 to 5, I need to include, which is present edge, direct edge is there, whose weight is 20. Next, 4 to 6, no edge, 7, no edge, 4 to 8, we have edge, and whose weight is 30. 4 is completed. Next, we will go for 5. So 5, so 5 to 1, no edge. 5 to 2, we have edge, but I have included using 2 comma 5. So we will test from 5 to 6. We have edge. So whose weight is 35. Next, 5 to 7. Yes, we have edge. And whose weight is 15. 5 to 8, we do not have edge. Then I will stop. 6. So 6 to 5, 6 to 1, 2, 3, 4, 5 need not to check, because already I have done that pair in the previous case. Next, sorry, 5 to 7 is already included. Next, we need to test from 6. 6 to 6 to 1, 6 to 2, 6 to 3, 6 to 4, 6 to 5 already included. 6 to 7, we have edge, and whose weight is next 7. We have only one edge from 7 to 8, whose weight is 50. So I have collected all the edges from this given graph. Next, what can I do? We have to sort these all weights and edges according to this weight. So here, this is the sorting I need to do. So first, what I need to do? This is the edge, and the next one, I am going to write weights this side. And this should be the ascending order of weights. What is the first smallest weight it has? This is 5. I am going to write this weight as 5, and the edge is 2 comma 5. So this one is completed. Next is the next smallest 10. So weight is 10 and edge is 6 comma 7. Next, third one is 15. So 15 is the next weight, and whose edge, which edge is 5 comma 7. Next 15, 20. So 20 is the next weight, and its weight edge is 4 comma 5. Next best is 20. 25 is a 25, and its edge is 1 comma 3. Next, where is 30? 30 is this one. 30. Next, 4 comma 8. Next, where is 35? 35, 35. So 35, and edge is 5 comma 6. Next, where is the 40 edge? This is the 40 edge, and its edge is 3 comma 5. Next, 45. So this is the 45, and edge is 1 comma 4. Next, 50. So this 50 edge is 7 comma 8, and its weight is 50. Next, last remaining thing is 55. Next, its edge is 1 comma 2. So I have sorted. This is the actual uh, edges, and I have converted this one to sorted type based on the weights. So once it is completed, next I will pick each edge, and I will I will draw, or I will include that one into minimum cost spanning tree. So before that, I am going to write the vertices, and one by one I will include. So first vertex is 1. Next, I will draw same graph at this side without edges. I will put only the vertices. So 2, this is 3, and this is 4, and I am writing 5 at here. Next, 7. Next 8 is this place, and 6 is at this place. So now I will pick one edge from this one, and I will include into this minimum cost spanning tree, and along with that I need to find what is the minimum cost. So I am going to take minimum cost. Initial value is 0, and one by one I will write it here. Next, I am going to include what are the edges we are including. I am going to note down at this place. So what is the first one? I have taken 2 comma 5 because its weight is very small. I pick this one, and I am going to test whether it form a cycle or not. So 2 to 5, when I connected these two, it never create a cycle. So I have included this one. So this is 2 comma 5 I have included. And what is the cost of this 2 comma 5? 5. So I have written 5 at this place. Next plus. Next, what is the next bit? Yeah. So what is the edge? 6 comma 7. So 6 is there, 7 is there. If I draw a line or if I draw an edge at here, is it form any cycle? No. So I am going to draw this one, and I am going to include this edge. Edge is 6 comma 7. And what is the cost of this one? I have written at this place. So this is also completed. I have included this one. Next, 15. So what is the 15th edge? 5 comma 7. So when I connected these two, is it form cycle? No. So that I am going to include this one, and I am writing 5 comma 7 at this place included this one. And what is the weight of this one? 15. Yes. Next one is 20. So what is 20? 4 comma 5. So when I connected these two, is it form a cycle? No. So I am going to draw the line between 4 comma 5, and the edge I have taken is 4 comma 5. And what is the weight of this one? 20. Next, 25. What is the edge? 1 comma 3. So if I draw this line in 1 comma 3, is it form a cycle? No. So I am going to draw the line at here, 1 comma 3, and I have included the edge. This is 1 comma 3, and its weight is 25. Next one is 4 comma 8. So when I connect to this 4 comma 8, is it form a cycle? No. So I am going to draw the line at this one, and I have included this one, which is 4 comma 8, and its cost is 30. So 30 I have taken. Yes. Next, I'm going to take 5 comma 6, another edge whose weight is 35. So where is 5? This one is 5, and I want to connect to this one. So if I connect these two, is it form cycle? Yes. So 5 to 6, 6 to 7, 7 to 5. So which is going to form a cycle. So can I include this one? No, I am going to exclude this edge because it forms a cycle. This I have written. Next, I will pick another edge. What is the edge? 3 comma 5, whose weight is 40. So let us go and test. When I include 3 comma 5 into this graph, is it form cycle? No. So that I am going to include this one into this graph, and I am going to pick like this one as I have chosen, and I am going to write this edge included into this minimum cost spanning tree. What is the cost of this one? 40. So I have write minimum cost spanning tree at this place. Next, I will go and test 45. So if I go for 45, is the edge of this one 1 comma 4. So when I connect this 1 comma 4, is it form cycle or not? Yes. So cycle is going to be formed like this. So can I include this one? I never include 1 comma 4. So I am going to exclude this one. So why I am ignoring this one? Because it is going to form a cycle. Next, I will pick another edge. What is the another edge? 7 comma 8. So if I connect the 7 comma 8, if I connect this 7 comma 8, happens, it will form a cycle. So what can I do? Can I include this one? I won't include this one. and I am going to represent this one, it will form a cycle. Next, and the last edge is 1 comma 2. If I include this 1 comma 2, again it forms a cycle. So again I am going to ignore this one, and why I am ignoring, which is going to form a cycle. So like that I have completed all, I have tested these all edges. Now I need to test a graph which it is generated is the minimum cost spanning tree or not. What is the first cost? What is the first thing? Whether all the vertices are included in the generated tree or not. Yes, all the vertices are connected with one edge. So it follows the first condition. Second condition. So is it forming any cycle? No. While I am choosing this edge, I have tested whether it forms a cycle or not. If it is forming a cycle, I have removed this one. So that no cycles, no cycles. Next one, all edges, all vertices are included. Next, and last thing, I need to test that one. Number of vertices is equals to number of edges plus 1. So what is the number of vertices? So total number of vertices are 8. What are the, how many edges are included? So first edge, second edge, third edge, 4, 5, 6, 7. So total 7 edges plus 1. So is it true or not? Yes, this is true. Yes. So what is the graph? Right now it is formed or generated. This one follow the rules of spanning tree. Okay. And which type of spanning tree it is? Minimum cost spanning tree. Okay, let us know what is the cost of this one. So how can I find cost? If I do the sum of these all, I will get the cost. So let us know 5, 10, 15. So this 15, 1 carry, 1, 2, 3, 5, 6, 7, 8, 9, 10, 10 plus 4, 14. So 145 is the minimum cost. This is the way you need to find the minimum cost spanning tree using Kruskal algorithm.